Right, looks like we are live. Hey everyone, we'll just wait for a couple of minutes for others to join in. And once we do, then we can immediately start with the workshop. So for those of you who have already joined, just a quick heads up, this is a very beginner friendly workshop. For those who aren't even like very sure about what Solidity is, or maybe how does even Ethereum work. So this is going to be a pretty basic workshop. It's going to be hands-on. So we'll be like building a very simple to-do list Dapp. And yeah, I can see someone has mentioned in the chat that Ganache should be installed. So yeah, since this is going to be, if you want to follow this hands-on, then make sure that you have Ganache installed. I think it's we have also sent that in the instructions. And yeah, you just have to install. Need not worry much about it. And I think it should be it. So this is especially for those who have not been able to make a submission at Eternals. So maybe you can just like follow this workshop, get to understand how a very simple Dapp works, even build it yourself throughout the workshop. And later on, you can make some more changes to the same Dapp, like add more functionality, or you can build something on the similar line. We also have Daksh with us, who will be later on sharing more ideas on what basic um, you know ideas you can build on in the next 2 days itself, which uh, since the submission deadline is on Sunday. So there will be very easy to build ideas shared so that you can at least make a valid submission in the next 2 days and get a hold on some of our exclusive swag. So like this workshop should be like, since it's a hands-on workshop, I will be waiting at certain points for people to like sort of finish writing the code. I think at max it should be 1 hour. And also, this workshop is being recorded, so this will be later available on YouTube. So in case if there's anything which you'd like to understand again, you can just check out the video again. We'll just wait for another 2 minutes, then we can start. Just to lay upon a few things. So maybe the prerequisites for the workshop would be at least like some basic understanding of web building or web development, because I really won't be going through the front end code. And just to keep it even further simpler, the front end is in vanilla JS, so it's going to be plain HTML, CSS, JavaScript, not even React. So in case if you are not really comfortable even with the front end stack, I think basic HTML is like a prerequisite so that you can understand, how to go about building the dApp. Smart contract is something we'll be looking primarily into. And I think some basic understanding of how code actually works, I think that should be enough. If you have done any language, I think, that should be helpful. I think we can start. So let me just quickly share my screen. Is my screen visible? Yep, I think the chat says so. Right. Let me just, yep. So yeah, so basically the theme for today's workshop is that we'll be building a very simple to-do list app deployed on like your local blockchain itself. And that is where, Ganesh comes into the picture. So we'll be getting to the details over there shortly. So just to quickly introduce myself, I'm Maniket and I'm the community leader at Dapp. And basically, this workshop is for those who have not been able to make a submission at ETHernals. So, with just another 2-3 days remaining, I think this workshop will be helpful for you to learn the very basics of dApp development. How do we write a basic smart contract and all these things to make a workable dApp. And after the workshop ends, you should be having a fairly good understanding of how this entire Web3 dApp thing works, and like how different it is from Web2. I think this should give you a fairly good enough understanding. And yeah, and then at the end we'll be sharing some quick, easy to build ideas which can help, which you can refer to. Even we have Daksh with us who will be sharing how to go about building on those ideas. And then in the next 2 days, since it's a weekend, you should have enough hacking time, and that should help you make that final push for ETHernals, and at least make something great out of this hackathon. And definitely for that, we'll be rewarding you with some of our exclusive shrines. So yeah, let's start with the workshop. So for setup, first we'll be using Ganache. So Ganache is basically to run a local Ethereum blockchain. So we are not actually going to be interacting with the Ethereum blockchain itself, since it's going to be costly. Like we cannot actually spend ETH over there. So local Ethereum blockchain is always preferred. You can also use something called test nets and all, where you can test how your smart contracts and everything works, if your dApp is working properly or not. And once you're entirely sure that everything about your dApp is working as expected, then you can deploy it to mainnet. So Ganache sets up a local Ethereum blockchain. So it's like sort of a testing environment for you. So you can just, I think, Daksh, you can just drop the link for Ganache. So in case those of you who are following this for hands-on, you can just quickly, it's a fairly simple installation. Just go ahead to the website. You can even Google it, just install Ganache on your system, and we'll get to that. Next is the Remix ID for writing and deploying a smart contract. So Remix is basically, again, it's pretty straightforward. It's an ID where we'll be writing our smart contract. So smart contract files are written in .sol files, .sol, and Remix provides us with the environment to sort of write and compile the code for our smart contract and also deploy it to whatever network we want to deploy it to. Like mostly it's going to be on a test network, which we'll be doing today, Ganache specifically. And third is your favorite code editor, whatever you use to basically write your code. So Remix is for our smart contract, and we will be writing our front-end code in Visual Studio Code or whatever code editor suits you best. So I'll be using VS Code. Just to get onto the very basics. So how does a dApp work? So I'll just quickly explain that. So instead of a traditional server and database in the backend, so let's take microservice architecture for example. So you have a front end, you have a backend. Backend is interacting with the database, that code, and that entire backend and database stack is interacting with your front end. So whatever requests you're sending to the backend to process the data or whatever it is, so that is how like the traditional in web 2 how it works. So in web 3 we have blockchain instead of our database and our instead of the database. And how do we interact with that is through our smart contracts, right? I hope this window is not causing any issues. I can just hide it. Yeah. So as you can see in the diagram here, this is I've taken from Preeti's blog. So as you can see, like, uh, there's your front end for the Dapp, which is written in JavaScript, HTML, CSS, whatever stack you're using, and that interacts with your Ethereum virtual machine. You must have seen EVM written all along. So and that interacts with the Ethereum blockchain. So what does EVM here and smart contracts mean is that smart contracts, we'll get to that in a bit more detail, but it's basically a set of instructions which you write on how the data should be managed on the blockchain. Right. Let's go to the next slide. So basically, again, like this front end, and this is basically in a traditional Web2 system. Here you would have at the bottom, you would have seen like a backend written in, let's say, Node.js or whatever it is, and it's interacting with your DB, let's say in Firebase or PGSQL, whatever it is. But instead, here we are interacting with the blockchain directly. I hope it's clear to you. I'll just quickly even take a look at the chat. Right. So, folks, if you have any questions, just put it in the Q&A box. I will be taking some questions like in between, and even Daksh is there to help you out with those questions. And I'll also be occasionally be taking a look at the chat. So what's a smart contract? So this is the official definition which you can find on the Ethereum website. So I'll just read it out. A smart contract is simply a program that learns on the Ethereum blockchain. It's a collection of code and data that resides at a specific address on the Ethereum blockchain. So just to sum it up, as I said, a smart contract is a set of instructions. It defines how data would be manipulated as per your requirements on the blockchain. And the smart contract itself, when you deploy it on the chain, it becomes a block of its own. It adds to the blockchain, right? So that is what it means here when it says that resides at a specific address on the Ethereum blockchain. So your smart contract itself will be having its own address. And yeah, and just a heads up that smart contracts can define rules like a regular contract and automatically enforce them via the code. And it cannot be deleted by default, and interactions with them are irreversible. So these things, that's the entire beauty of blockchain, right? Everything is transparent and all those things. So it's better to always test it on your test nets. And then once you're entirely sure, once you've done the end-to-end testing, then only you deploy it to the blockchain. And for beginners, we don't expect you to submit a working Dapp, like a working Dapp on the Ethereum blockchain itself. Even if your Dapp is working on a testnet, it's good to go for a valid submission. So you need not worry much about that. Right. Next. So yeah, to-do list Dapp. So coming to like the flow of the workshop today. So the first thing we'll be looking at is creating the smart contract itself. And is creating the smart contract itself. Then we'll deploy it on our local Ethereum blockchain. We'll build the front end. So front end won't be spending much time actually writing the code. I have it on GitHub here, so I'll be dropping the link. You can just copy paste the code for that. But the JavaScript part where it's interacting with the block with your smart contract using Web3.js, this fourth point is what we'll be talking about in a bit more detail. So I think we can now start with our hands-on. So the first thing you have to do is go to Remix. So it's just remix.ethereum.org. And I think I already have it open here. So once you open Remix, you'll be able to see like a file structure, or like your ID will immediately open up with some sample code. So let me just create a workspace. To-do list map tutorial. So this opens up a new workspace for me, which has its own, like there is some template code which you can find. So we'll not be really using this. So I'll just go ahead and delete them. And what I'll do here is I'll just create a new file called to-do list.sol. Right? So just for now, just make sure whatever I'm writing, let me, there's something on the chat. Daksh, I think you're sending the links in the hosts and panelists part. So just make sure that you're selecting everyone when you're sending the messages. Right. Yeah. So yeah, coming back to this, so you just have to create a file under contracts, to-do list.sol, and we'll just go ahead and first create the smart contract. So first thing, like it's a good practice to always declare like the version of Solidity you're using. So as of now, we are going forward with 0.8.7 for this workshop. So just make sure that that's the first thing you do. And the caret sign here just means that it's also it will compile for further versions ahead as well, right? Once that is done, so this is going to be very similar to how object-oriented programming works. So how we create class objects, pretty much a lot of things you'll be able to see here. So instead of a class, so basically how I'll be taking this workshop, especially for the Solidity part, is like I'm going to point out similarities between how it works in traditional object-oriented programming, let's say like Java, C++, whatever you have done with the very basics. And we'll be making some similarities so that you can understand it better. Right. So instead of a class, we write a contract here. So let's just call it contract to-do list. I hope the font size and everything is visible. If there's any issues, you can just basically point it out in the chat. Right. Sanjay, if there's anything in the chat, feel free to just interrupt me in between and let me know if there are any queries. I'll just increase the font size. This should be better. Yeah. All right. So this is the way we define a class. That is how we define a contract here. So next, what we are going to do is write the state of this smart contract. State basically means the data. So we'll be breaking it down into a struct. So I think those of you who have done C or C++ are aware of how a struct is. So basically, it's just like how do I say? It's a user-defined type where you can create data types of your. So basically, it's your own data type, and inside you can create using the traditional data types which already exist, like string, int, whatever it is. So basically, this task is one data type. I also have some diagrams which I'll be showing here. So struct task is one data type. So it will be defining each and every task. And what properties does each and every task have? One thing obviously will be the name or whatever the task itself is. Let's say pick up my laundry or go for a jog or whatever it is. String task name is how we're going to be defining it. It's going to be a string, basically, whatever we will be storing that. And next is a Boolean. Boolean, basically, I think most of you would already know that it's just true or false. So if the task is done, so we'll be storing that if it is true or false, so that it will display accordingly. So this is how our struct task will be looking like. And just to further explain this with a diagram, yeah. So this is our struct. Like this is how it is going to look right now. And when we create an array of tasks, so this is how it's going to look like. So there's going to be like an array. I'm pretty sure most of you know what an array is. And as you can see, like, yeah, so since it's an array of tasks, so there's going to be multiple struct tasks, and each of them will have its own property, like the name and the is done state, whether if it is true or false. So each user will have multiple tasks, right? So this is what it currently looks like, right? Okay, next, this is a bit of a tricky part of Solidity. Like it's basic actually. Once you get the hang of it, it becomes very simple. So I'm just going to write a sentence. You can just copy it down, and we can then get to how why did I exactly write it. So it's going to be mapping address task. Just write this down. We'll get into why did I write this, how did I write this, what are the important things to highlight over here. So let's come to the mapping part. So I hope most of you know what a dictionary is. So dictionary is basically like it's a collection of key value pairs, right? So like there's a key and there's a value, key value, right? So that is what a dictionary is. So when you use something called mapping, so in Solidity, that will create a dictionary for you. And address over here is again a data type. It's a keyword here. So address basically is literally the address of whatever the user is on the blockchain, whatever address they have. Like it can be also, it can, so whatever user there is, they have their own addresses, right? Everyone has their 0x address. So this data type stores that address. You don't have to store it in a string or something. There is a defined data type for that. So mapping address arrow operator to an array of tasks. So this basically means that the key of the dictionary will be an address, and the task and each address will have an array of tasks. Right. I hope this part is clear. So it will end up, yeah, sorry. And then private users. Private is basically just to limit the scope of the users, and basically this entire thing becomes a variable declaration sort of thing. So this is the data type, which is like the dictionary itself, and how the dictionary will be. It's going to be the key of the address. The key of the dictionary is going to be address, and the value will be an array of tasks. I hope all these particular points are clear. So it's going to end up looking like this. So this was the code which we wrote. So basically users will become a dictionary with the key address, and each address will have its own array of tasks. And this is the same thing as this, right? So address 1 might have 3 tasks. There's another address which might have 2 tasks. Address 3 will have two tasks, whatever it is. This is just an example. So when you write this, it ends up looking like this. So this is basically what you'll be storing on chain. Like what tasks do each users have? So the users are defined by their address. Let me just take a look at chat. Yep, you'll be getting a recording ahead as well, but okay, we'll share. I'll also, by the end of the workshop, I'll share the Excalidraw sheet. And also, yes, it's going to be available on YouTube, but it's better to like follow it right now. And whatever queries you have, just get it resolved over here itself. I can see there's one open question. So while mapping, by default, whatever length of list is, will be the length of, sure, the question is. So basically right now it's going to be dynamic. Like there is, so it's basically like when we declare this, it's basically empty. And whenever we want to add, we'll push to that dictionary. I hope that answers your question if that's what you're looking for. Yeah. Okay. Let's get back to the smart contract. Yeah. Right. So let's create. I think this part is done. So we have our data set. We have our data ready, like what our task looks like, and how we are creating it for multiple users. So coming next is like, how do we manipulate this data? And that is like, whatever CRUD operations are there, we create a task, like we add it. Basically, there's going to be add, there's going to be delete if you want to delete the task from the block, from like your list. If you want to change the status to done or not done, or if you want to update it or whatever it is. So this it's going to be very simple now. So let's go ahead and create the add task function now. So basically, what function I'm going to write is basically just to whatever list of tasks we have, we just want to add one more task for that particular user, right? So it's going to be a simple function add task. So just copy what I'm writing. We'll get to the details of it. Call data underscore task external. Let's tackle this function declaration which we have written. So function add task, I think that's pretty straightforward. String call data underscore task. So call data is basically an equivalent to const in your JavaScript, where we are just storing it for manipulation. Like if we want, so basically this underscore task will be receiving it from the front end that, hey, this is the name, this is the task, and this is like the string of the task. Like this is something I want to add to my list of tasks, right? So that is why it's taken in string, so that we can assign it to the task. All right. So that we take it in as a parameter, and external simply here means that this particular function will be available to the front end code to interact with. So there are some, you can write some functions which are not available for the front end, like for internal working of your smart contract. You can write functions which are not external, which is just helping with the internal working of the smart contract. But external means it's like it's going to be available to the front end to call and whatever execute that particular function. So in terms of, if we talk in terms of APIs, so this is an API endpoint available to the front end. Those of you who know Web2, I think this should be a good enough example. Right. So what we're going to do is that we have to push it to our existing state, right? So it's going to be users at message.sender. So basically, whoever is sending that address will be receiving it. So as you can see over here, one sec. So these are the addresses, right? So user at this particular address will give access to that particular task list, right? So this will be getting it from the front end, and this is how we define it. That message is coming from the front end, and who's the sender, and that will give us the address, like the data type address itself. It's going to be of address data type, right? So when we type this, now we have access to, let's say we called it for address 1 year. So it means that we have access to this array, which is a list of tasks, right? And to this, what we are going to do is we are going to simply push. So push, just it's simple JavaScript that we append to the list to the array. It's that simple, right? So what are we going to push? If I want to add another block here, so it means that I have to push another task block, like this struct task, this kind of block I want to add, right? So let's go ahead and just do that. Task, it's going to be in round brackets, and then the struct itself we're going to write. So be careful of the syntax which I've written here. And what the struct is going to look like. What do we have to manipulate here? Since we are creating a fresh one, so we want to edit these two things, these two properties of the struct task. So first thing is the task name, and the second thing we want to edit is the is done part, is done property of our task. So task name, what it will be, it's going to be underscore task. Pretty straightforward. The task name, we got it here when the function was called, and we just assign it over here. I'm just going to add a comma, and is done, we'll set it to false. So makes sense, right? Whenever you create something new in your to-do list, the default should be false, that it is not done. So we are just going to put that here. We're just going to end this with a semicolon, and that's it. You have written your first function in your smart contract. So I'll just wait for 1 minute. You can just quickly go through this. And Daksh, if you can also send the link to my GitHub repo. So for those of you who have missed writing some part of the code, you can just go to my GitHub, go to contracts, you'll find the to-do list.sol file. And whatever you missed, just copy paste it from there. But focus more on understanding what I'm writing here and why I'm writing here. Syntax, you can just copy paste from the code. Right. Let me just take a look at the chat. If there's anything, any open questions. I can see someone else. Can you please explain that external command? All right. So basically, let me try to give you a good example. All right, first let me explain it, how it actually works. Is that so if I don't write external, it means it's not available not publicly, but to the front end you are connecting it to. When I write external, it means that this particular function, that is add task, it will be available to the front end. So the front end takes the information from the user, like, okay, this is the input for the task which I need to add. Now you want to call this function, right? So that it actually adds the task to the blockchain itself. So for that, I want to interact with my smart contract. And I will only be able to interact with add task only if it is defined as external. So it means that it's available to the front end. And if I don't write external here, it means it won't be available. So in the front end, if I do contracts.methods.add task, it will not access it because it's not publicly available, or yeah. I hope that answers your question, Srila. Yeah, you can sort of consider it in that way. Yeah. Let's move ahead. Rest of the things, let's try to cover up pretty quickly because I think we are running short on time. So next, let's just write the code for actually getting the task. So when I want to show all the data in my front end, so there has to be a get task function, right, which gets the task from the blockchain and lists it down on our website, right, or Dapp, let's say. So oops, yeah. So let's just create a function called get task. Again, I'm just going to be typing it. You can just follow it along, and we'll get to the explanation soon. Right. So again, since this will be external, because I want this to interact with my front end, view returns task. So don't worry, we'll just write this down first, and we'll get to the explanation later on. Right. So function get task basically just to get the task from our data and send it ahead to the front end, right? So external, already explained what it does. View, basically we are explicitly defining the fact that this particular function will not mutate the state of your data. So it's not going to edit. This is get task, right? We don't have to make any changes to the existing data on the blockchain. We just have to view it. We just have to get the data. I'm not going to manipulate anything over there. So view strictly defines that this function is not going to change any data on the blockchain for this particular code, this particular block. So here we didn't add view in the first function for very obvious reasons, because we were editing the data, right? We were creating another task in our mapping, right, in our dictionary. So okay, here it's just getting it, so we have to write view over here. Coming to the next part, it's returns. Sorry, so returns, we are just defining what kind of data type it will return. So it will be returning a task. And memory here is just another data type like call data, which basically is like your let or var of JavaScript. It's going to be that simple. So we have now just explicitly defined that what kind of data will be returning. So we'll be returning task, right? Yeah. So let's just one more thing. Forgot to cover this. Uint task index. So task index is very simple. It's just like 0, 1, 2, 3, whatever it is, because each user has this list, right? So 0, 1, 2, which task do I want to get? Do I want the first task? Do I want the second task? Sorry, I mean, this is the second task and third task, technically. So whatever it is, that particular index is what is expected in the function here. So I want that task index. So what I'll do is, first thing I want to, so I have the task index. So I'll create a task memory, let's say task, just name it very simple. And we'll just fetch that particular, sorry. And okay, so when I write this much users at message.sender, so I am here. Let's say it's address 1. So I am at this part. Now I want a particular task. So it means I'll just refer that particular task index. Right. I hope this part is clear. Right. So this way I have now received that particular task which I was requesting into this variable called task. And this is what my function will be returning. And this return, this will go to the front end. Right. I hope this part is clear. Any questions here? I'll just take a. All right. I think Rishabh, Daksh will be taking up the question. Okay. Uint is basically, it's unsigned int. So you can just consider it as your normal int, but in Solidity, Daksh can drop resource for like a bunch of resources for Solidity syntax. So instead of int, we just write uint here, which basically stands for unsigned int, which you can just treat it as a regular int. All right. All right, good questions. All right, since we are running a bit short on time, what I'm going to do is I'll just copy paste the. I think by now you have gotten a fair idea on how do we write these functions to access or manipulate our data. So what I'm going to do is, like the rest of the code, I'll just quickly copy paste it, and also we can go through it to understand what the rest of the functions are. So I think we have done it in the get task. Okay, let's just keep the last function waiting. Let's add these two. Okay, so let's quickly go through the new functions we have added. So function update task status, pretty straightforward here. Basically, this function is to update that task, if it is done or not. Is done. We just have to update the is done part of that particular task, right? So what inputs we are expecting here? One is the integer task index. So obviously, like which task should I did the first task, second task, third task. So I need the task index for that. And the second parameter which we are expecting here is the status. That what status do I set it to? Do I set it to true or do I set it to false? And we are just going to write external here, since this will interact directly with the front end. No view, no returns. View, we are not writing view, obviously, because we are actually changing the state in the blockchain. The data is being changed here. We are updating the status, right? So that is why we are not going to be updating the view. That is why we are not writing view, because it's actually updating the data, and we are not returning anything. We are just going to we are just updating it. So we don't have to return anything. So that's why there's no returns ahead of it. All right. And how do we do this? Again, same thing. We have our users have our users state. We access that particular address. So we have a list of tasks, and in that list of tasks, we then access the task by its index, and its property is done. And we just set it to the status which we have received from the frontend. Very simple, very simple. Right? Update task status done. So I think the link to my GitHub is already sent. You can just copy paste it from there. Just let's focus more on how are we writing these functions, and what's the intent behind it. Okay. Second last function is delete task. Like if we don't want that task to be on our to-do list anymore. Again, what do we need for that? We need the task index that we want to delete that particular task only. Again, it's only going to be external so that it interacts with the front end. No view, because we are actually updating the data on the blockchain. We are deleting that task from existence. So we do not need view over here. Return, we are not returning anything. We are just manipulating the state on the blockchain. Right. So that's why how do we do that? There is just literally like a keyword called delete. And how do we access that particular task which we want to delete? Users at message.sender. So that gives the address, and which task is given by the task index. Done. All right. So even though my code is actually available publicly, you already have the link and all, but still I would like to take 5 minutes for you to try to get the length of basically the length of the task list array. How many tasks for that particular user exists. So I'd suggest I'll give 2-3 minutes here. Even though my code is publicly available, just give it a try. Try writing this function yourself. So just to repeat, the function of this function is going to be to return the length of the task that particular user has. Like how many tasks does he have? Does he have 3, 2, 1, whatever it is? We want to return that. So I'll just give 2 minutes. Meanwhile, I'll just take a look at the chat. And please try to do it yourself so that you are very sure that you have understood how to write a function in a smart contract. And later on, even if you're not able to figure out, no worries. We'll get to the code, we'll write it, and actually get it done. All right, I can see how would we proceed if we want to add a feature to save all tasks that have true for is done, basically to keep a track of all that I have done. Do we create one more list like another way to do it? So what we can do here is that there's going to be another function which is going to basically okay. So one thing we can do is we can iterate over all the tasks in that particular user. So it's going to be like users at message.sender at so dot length. Basically, we'll just get the length of it and we'll iterate over all the tasks. And for each task, like for I equals 0, I less than length, I plus plus, and users message.sender at I, so that we have that particular task dot is done is true. So you can just create a new function called function update task to update all tasks to true. And that would be the code inside. That's one way to do it if you want to have a function. So those things you can do after the workshop once you have the code ready, basic how it's working. And then you can feel free to experiment with the smart contracts, whatever you want to write. That should be a good way to go. Good question. I'm not really sure what's the issue with your Ganache. I think you can just reinstall because I think for most of everyone else, even including me, I think Ganache was just to install and we just have to run it. It should be pretty straightforward. Make sure you're running it with admin and all. I think that should also count to that. All right. I hope you guys, folks, like try to write the task count function. So let me just finish writing it over here. So it's going to be get task count. So basically, I want the number of tasks, like how many are there. Don't need anything from the input. Like I just have to send the particular count. External going to be there. We are not manipulating the data here. We are not changing anything about the data in the blockchain. So it's going to be just view, and it returns a event. I hope this part was clear. And we are just going to simply return users at message.sender. Now we have that particular list. Let's just get the length. Done. Just saving this. All right. So this brings us to the end of the smart contract itself. There's one, it's that SPX warning. So this is just so that you have a license identifier mentioned. You can just add this on top of your smart contract. And this should do it. Right. So there it is. You have your first smart contract already there. It's all ready. In case you missed anything, what you can do is you can just quickly go to my GitHub, copy paste the entire code into this, and let's go ahead and deploy this on our smart code. On our local blockchain. Yeah. So go ahead to the Solidity compiler. Let's first compile our Solidity, our .sol file. So whatever file you have selected, it will automatically show there that you want to compile this. Let's just go ahead and compile it. And it has, on saving, it automatically compiles. There should be a beautiful green tick over here to show that, hey, good job. It's all good. Syntax wise, it's all good. Yeah, that should be it. So you have compiled your Solidity code. Next thing, let's get back to the presentation once. So now we are going to, our smart contract is ready. Now let's just go ahead and deploy it on Ganache. So just quickly start your Ganache. I think my Ganache is already done. So this is what you'll be seeing first. And this is a weird name. We don't want you. So this is what you'll be seeing here. And what you can do is just, you don't have to really go into setting up the workspace. I think quick starting a workspace should be enough. So once you click on quick start, so there's literally a blockchain running on your system, which matches Ethereum, and do not get very excited. Not everyone is getting 100 ETH over here. This is all just for testing. So this is your local blockchain, so it doesn't really hold value, right? So this basically has given you some addresses which has some balance on it, and here is where we'll be deploying. So this is our blockchain. This is our blockchain running on our PC, and it is being served on localhost :7547. Right? This number is something I'd want you to take a look at. Right? And you can, right now it's going to be empty. There's nothing we have done right now. No contracts deployed, no transaction, no basic, just, there's nothing over here. Let's go ahead and connect our remix to our Ganache. Right. So how do we do that? We go to deploy and run transactions. So first, we have to select which environment do we want to deploy on. So there are other VMs and all which you can deploy on, but since we already have Ganache running on a system, I'm just going to go ahead and click on Web3 provider. since Ganache is our Web3 provider. And before you go ahead and click on OK, the Web3 provider endpoint should be 7545 as we saw earlier over here, because this is where it is being currently served. So just make sure that you're making the 7545 so that it connects for sure. Right. And I think it has successfully connected, because I can see that the default account it has taken is 0xbe1, which is the same address here. So it means that it has successfully connected. Remix has sort of connected to your Ganache. Right. Need not worry about all these things right now, since it's very beginner friendly. You don't have to worry about all this. Make sure that contract is to-do list, and let's go ahead and click on deploy. Right. So once you click on deploy, you can go on transactions and see that, hey, contract creation is there. It means our smart contract is on our local Ethereum blockchain now. And once you expand this list, you'll be able to see all the functions which you had created. Right. So add task was there, delete task was there, update task status, get task status, get task count. So let's just quickly do a test here. Even you can follow along. So I'll add a task. Let me just put this in strings. Let's say build a quick Dapp. This should be my first task. And once you write it, you can just click on add task. Does this open the console? I think this has run. Yeah, we have another transaction. You can see that, another transaction has been added. So basically, whatever state changes you're doing, whatever data changes you're doing, or however you're interacting with the data on the blockchain, it is its own transaction. Everything is a transaction. Even if you're just fetching the data, it's also a transaction. Right. So build a quick Dapp that has created so for this particular address 0xbe1. So let's say I am 0xbe1. So for that particular address, it has added a task in the task list called build a quick Dapp. Let's just populate it with one more. Submit project for ETHernals. Right. I'll just go ahead and click add task. I can see there's a successful transaction. Yep, it's working. And let's just go get task count. And you can see that, hey, there's a unsigned integer which has 2, and that is exactly the number of tasks we have added. So it means our functions and all are working. So, if you want to quickly check your functions on the smart contract, you can interact with them from here itself. Right. Let's do a get task also. So for get task, we need to pass a task index. So let's go ahead with 0. And you can see it returns a tuple, which is basically like our task is basically 2 things, right? The task name, as you can see here, and the is done state. So build a quick Dapp is false, which was our first task. And let's just also go ahead and check this one. Submit projects for ETHernals is false. So it means this is a good enough way to test your smart contract. And this brings us to the end of the smart contract part of the workshop. Right. We have only 6 minutes, so let's just quickly go ahead with the front end part. So front end, just go to my GitHub. The link is already shared. Go to front end. You're going to see an index.html. Let's just copy that real quick. I'm just going to pick this up from here. I have my VS Code already open. Make sure that you're also creating. Okay, so I'll give you some time to go ahead and create a folder structure. So this is how it's going to look like, right? Let's get back to my GitHub. Yeah. So there's going to be contracts you don't have to worry about right now. So just to store the code, I've written contracts over here, but this actually exists in your Remix right now. But whenever you're uploading all your code to GitHub so that you submit it for ETHernals. Just make sure that there's one more folder called contract so that we know that all your .sol files are here. Right. Yeah. So frontend, just create this folder called frontend. Over there is going to be one index.html and a folder for JavaScript, which will have all these files. So let's take the index.html, paste it right over here. And this is basically just like, I'm not going to go through HTML. You can just go through it, see how the front end is built. And I think we can go ahead to the more important part, that is like the JavaScript working of your app. Right. I can see there are no open questions. I'm just going to wait for 1 or 2 minutes. Folks, if you are following the workshop, everything is going smoothly. Just can you just like give me a heads up on the chat? I would be appreciate. So if till now everything, like if your smart contract has been deployed on your local blockchain, just put a let's not just put a thumbs up. Let's just put like a confetti emoji because we have built our first smart contract all up and running. So if you have deployed a smart contract on your local blockchain, let's just go ahead with the confetti emoji. Let's go. Yep, can see some emojis. All right, awesome. Let's quickly get to the code part, the front end part. So index.html already created. You have the file here. Let's go ahead and start writing our JavaScript. So again, since we are already short on time, let's just go ahead and copy paste the code and focus more on like understanding how it works. We have our JS here. So let's go ahead and first create. So there are 3 JavaScript files. App.js is for like actual working of your, like you're manipulating your front end. You're manipulating your HTML to display this particular thing, add class names or whatever it is. That's how front end works. Config.js to add your configurations for so that you have all the correct configurations in your JavaScript, like your account, your contract address, and all these things. I'll be explaining it later on. Need not worry much. And get account JS is simply to get which account will be used for maintaining the this thing. Like from which account the transactions will be happening. We'll get to that. Right. So I think the easiest part is let's just go ahead to let's just create account.js, get accounts. Just be very sure of, yeah. Oops. It's going to be get account.js. Right, so I've created the file. Go to my code and let's copy paste this. Copy pasta. Right. So let's go through the code here. So okay. So first things first is that we are including all of our JavaScript files over here. Yeah. So there is something called Vec3.js. Daksh can drop the link to further, if you want to go through the depths of like what functions are available in Vec3.js and all those things, what each of these particular terms mean. So we don't really have to have the time to go to the very intricate details, but let's do a quick overview. So the rest you can check out the documentation and learn more about it. Tons of YouTube tutorials or even like other tutorials you can find online to understand that. Right. Most important thing here is where your blockchain is actually being served. So right now we are connecting to our local host because that is where our Ganache is running. Right. Let me just here is our server where it is running, HTTP localhost 7545. So make sure that, in our Web3 providers, as you saw, right, there were multiple Web3 providers. There's one in London. There are many other uh, ways you can provide that particular thing. But here we are using Ganache. So that's why there is a localhost provider here, right? And async function get account. So async is just to declare asynchronous functions. I'm not going to go in the depths of JavaScript. And first, we are fetching all the accounts we have on our Web3 provider. So this is the Web3 object we have created, and it has, and we get all the accounts here. And the default account is the account at 0. So basically, whatever the first account is. So when I say it's fetching accounts, it's getting all these accounts which are available on the blockchain. Blockchain means our own local blockchain. So all these addresses are getting fetched. And just to maintain simplicity, we are just going to be using the first address. So that's why accounts at 0. We console log that, hey, it's connected now. Like that account has been detected. So we have to, and we just return that particular default account. Cool. Now let's go ahead and create our config.js file. Here, let me again go back here. Okay, config.js, don't copy paste it. Let's actually just do it the proper way. So there are two things which we, just give me one second. Yeah, just go ahead and create your config.js file. There are two things required here. One is going to be your contract ABI and the address itself. So ABI. So ABI basically is like the compiled code, like Solidity the Solidity file is written as per our understanding, right? We have function, that all these things. Once we compile it, we get an ABI which is understood by the Ethereum blockchain itself, if I'm not wrong. So I think the best example here would be is that we write our code in C++, but at the end the machine reads the byte code that is zeros and ones. So that is like, I think, the best way to explain this, right? So let's go ahead and just set up our config for that. So let's go let contract ABI. This is one thing you have to write. And the other thing is the address. So let contract address, right? So these two things we have to get. So where do we get that from? Go back to your remix. Go back to the compiler here. Yeah. Just close this. And okay. So the I think ABI, we find it over here. Yeah. So go to your Solidity compiler first to get the ABI, and you can see, like, there's a copy over here. So let's go ahead and just copy that. And this will be basically like, just make sure that it is enclosed between square brackets. So I'm just going to hit paste here. Oh, wait, you don't actually have to add the square brackets. It's already added, I guess. Yep. Yeah, it's already added. Yeah, so this is your contract. So if you want to go to the details, you can actually just give it a quick look that, add task, there is no output because we are just adding the task. What inputs do we need? Internal type string, name, what is the name, and the type is string. So it basically just makes it understandable for the compiler. It's for the compiler itself, right? So we just set that here, and the contract address. Oops. The contract address here is going to be. Let's go back to our. Yeah, let's go back to our deployment, and we can get the to-do list at 01xbc, whatever it is. Let's just put that in between these codes. So this is how you get the contract address. So okay, just to quickly go over that. So we can, it's written here, right, that a to-do list is deployed on 0x1bc. So as I mentioned, right, when you deploy a smart contract, it also creates its own node on the blockchain. So let's also open Ganache. Let's go to blocks. Let's actually go to transactions. Yeah. So yeah, you can see like contract was created over here, and the created contract address is exactly where it is deployed, 010x1bc. So this address is for me. You will be having different values on your end. So I hope you have set this properly. I'm just saving the file here. This is not something you can directly copy paste. So I hope this is being connected properly, right? And I'll just give 1 minute. Let's try to wrap this up ASAP. Right. Quick walkthrough. We created 2 JS files till now, JavaScript files. One is get account, so that we get the account from our local blockchain, which is deployed at localhost 7545. And we take the default account for all our transactions. And then we create a config.js file. So contract ABI again is like a translated form from Solidity to something which the compiler will be using. And then we create another variable called contract address, is where our contract is deployed. We need that address so that we access it, right? All right, let's go ahead and create the final JS. It's going to be app.js. Wait. Yeah. Good. Let's go ahead to my GitHub, get this entire code. So I don't get intimidated. You'll feel there's a lot of code here, but if you're fairly comfortable with JavaScript and how HTML and all is being manipulated, you should be able to understand this real quick. Not a big deal. All right. So one second, I think I can see a question here. Any questions? The chat is empty. Okay. All right. Daksh, I think you can take that question. I'll just go ahead and quickly finish up the workshop. Yeah. So folks, once you copy paste the code here, so let's only go through the important parts. So one is like create task list. So create task list basically means that we are going to get all of our whatever task exists on the blockchain. I first want to get it to my front end, that is the Dapp over here. And then I will populate my HTML page with all those tasks and whatever status it is, right? So we get account first. This get account we had created in our get account JS, right? Yeah, and then we get the contract by passing on the contract ABI and contract address. Daksh has already shared the resources. So if you really want to go to the depths of understanding how all these things work, you can just refer the docs over there. Right. Then we have a quick try catch to understand, like to basically try to get all of our tasks. So first we get the number of tasks, like how many tasks do we want to, like the number of tasks which has to be displayed. So we need that beforehand. And as you can see that the contract which we have set here, then each contract has its own set of methods. In our case, we have, I think, 4 or 5 methods. And from that, I'm calling get task count. And this get task count, if you remember, yeah, get task count is exactly what we have written here. So basically, this will return us the length, right? Getting back to the code. And then I am calling this function using which address? So message.sender, right? I need to give that address to the sender, message for the message.sender. So I sort of send ahead my default account, right? I hope this makes sense. Right, what does try in the code mean? I think this is a basic concept. This is not really only related to Web3. Even in Web2, try catch blocks exist. So I think that is more of a basic programming concept. So you can later on just Google and see, what are try catch statements. If you have done Java, C++, I think you should be able to understand it. Right? And that way, we have the number of tasks, and we just like console log it for our own, uh, like just to refer. If number of tasks is not zero, if we have tasks, then this is all yeah, task iterator less than number of tasks. So basically, like we'll be iterating till we reach the total number of tasks, right? 0, 1, 2, whatever it is. And um, the task iterator is basically the index, right? The 0, 1, 2 at which our tasks are present. And we use contract methods to get our task. Get task is again the function which we have written in Solidity. We pass the index. It is called using our default account. And we have that task. Okay, let's go to get task real quick. I'll just open it on my GitHub here. To list.sol. Get task. So we return a task here, right? Of type capital task. There's a lot of tasks. So that is what we get here. And we then just like this add task to list is again an HTML function. Once you go through the JavaScript, you'll be able to understand what HTML functions are there to manipulate it and all. So we just send it the task iterator, task at 0 and task at 1. So task at 0 is basically the string name, and task at 1 is the status. All right. So that way, we sort of create our task list, and rest all of the things are same, like remove task, change task status. So in remove task, you can see that we are calling a delete task function using the same contract dot methods dot delete task. In our change task status, we are calling our update task status with the required parameters, that is the task index and what is the status of the checkbox, which we have true or false, and send from our default account. Then add task. How do we like add task to the chain? So it's contract.methods dot. First we get the task count, and then +1 to it, we add the task to the list. And add task to list is something we have already covered. Right. And add task to list is here. This is all HTML code, no Web3. I've put some more comments for you to understand. This is all related to your HTML manipulation. It looks very crazy right now. Personally, I would rather do this in React, since state management and all is better in React. But just so that you folks can understand and deploy it on a basic vanilla JS front end, that's the reason we have done it here. So you can go through the code later on, right? Let's just go ahead and test our code. So I'm just going to go live. Basically, you just have to open your index.html, and voila, we have our to-do list. And since on our smart contract, we had already created two things, right? Build a quick dApp and submit project for ETHernals. So we already have this. So build a quick dApp. Let's just mark it as done. And I think this also updates on our Ganache. So yes, sorry, task. Let's add a task to see our transaction. Let's just say get ETHernals swags from the folder. I'm just going to add a task here. Oops, didn't add. Let me just check why it's not happening. Looks like I've done a typo. Oops, there has been a typo. Let me just quickly get to that. Give me a quick second. Huh? Folks, meanwhile, you can just check your code as well. Let me just fix my typo here. Let me see where is it breaking. Meanwhile, you can post any questions if you have. All right, yeah, I got it to work. Let me just quickly go ahead and share my screen. Where is it? I don't think my screen is visible. Let me just retry it. Right, is my screen visible now? Yeah, awesome. Yeah, so let's just go ahead and create a task. Let's say get receive swag from Deffolio for Thermals. So as you can see, this task has been created, and this should also reflect on my Ganache. Yep, right over here. And you can go ahead and mark something as done. So we have already built a quick tab. You can mark it as done over here, and other things like I think to delete a task, you can just double tap on the task and delete task function is called, and marking the checkbox. This updates the status. Um, you can just do another sample task, that task. So everything is pretty much working. And the get task count is helping update the number of tasks here. Right. So any of you who have got it to work, you can just put it in the chat. This is basically brings us to the end of the workshop. We have a working Dapp at our hand. Uh, so basically, this should be a good start for those of you who had, fairly a bit less idea about how the blockchain, how to build on Ethereum and all those things. So, happy to answer any questions, even on Discord. I'll be available. Any questions regarding, how to create a smart contract and all those things. The recording is available. You can, revisit the workshop. Anyone who has got it to work, if you can just put it in the chat that, let's put a rocket emoji if you have got your DApp to work. Yes, I'll be sharing my Excel sheet. I will. All right, I can see someone has deployed their code. Great job, folks. For submission, we upload GitHub repo. So yes, once you have it all running, so you can just let me just show you my code structure. Yeah, so as you can see, I've created contracts and frontend. So you have already maintained your frontend code in one place. In the same directory, just create one more called contracts. And if I go to contracts, you can see that I have a to-do list.solve. We have a to-do list.solve, and that basically has my code, right? So create this repo, and then you can just go ahead and basically submit it on Deffolio, with other things which are required in the submission. Yeah, I mean, this was it from my end. Let's also quickly go through a bunch of basic ideas you can build at ETHernals. So easy to build ideas. We have Daksh with us who will be sharing some ideas, and we'll also be sending you the doc over the email later on once the workshop is over. So over to you, Daksh.
Hey folks, I'll be sharing the screen. Give me a second. So I hope you can see my screen right now.
Yeah.
So this is a doc that I built that I wrote for some basic ideas that you can have. So here are the resources for Ganache Remix and the code that were in the work used in the workshop. So in this list, I have created a basic TLDR of the project that is going to build, and a tutorial with a link to a tutorial which would you can like follow along and basically understand how things work. So this is, for example, a ship a dab, which means NFT with a button click. So what you can do is just click on this and it will take you to a alchemy tutorial. You can follow along. It shouldn't take you more than an hour or two. And since you have the weekend to yourself, and you can build. There are these 4 projects, and all of them have a tutorial with link to them. Feel free to reach out to us if you have any queries. Just tag me on the Discord query channels, and I'll definitely be able to help you out. And yeah, so I'll share this, Aniket, and I will share this doc with you soon. So yeah, this is it from my end.
Thanks a lot, Daksh. So yeah, folks. So basically, like this was it for today's workshop. Hope you've gotten a basic idea on how to write a very simple smart contract, deploy it, see how it looks in the front end, and we'll be sending over the Notion doc where you can follow some tutorials to build projects of your own. Although we'd really appreciate if you don't simply copy paste the code and just make a submission at ETHernals. We hope that you get some understanding from the project and at least make some tweaks from your end. Like I think someone in the chat earlier mentioned that if we have a function to check all tasks with one click, so try to make more edits on your end, and feel free to mention it in the about section of your project that hey, this is something I took help from this tutorial, and I built more. These are the features I've built on top of what we already have. So this way we'll definitely be counting it as a valid submission. And even if you're feeling, don't really overthink about how your submission looks like and all. We'd suggest that go ahead, make a simple dApp, just submit it to ETHernals, and this way we'll at least be eligible for the swags. And the swags are basically just our way of appreciating your efforts for you've put into the hackathon, and also taking your first step in Web3. So if you have any doubts, we'll be available on Discord. And there are only 2 days to go for Eternal, so make sure that you're making that extra push in the last 2 days, and going ahead and making a valid submission. And the Excali sheet, need not worry. We'll just I'll collate all the resources and I'll be emailing it and or sharing it on Discord itself. Right. That's it, folks. Thanks everyone for joining. Right. See you, folks. Right. Good luck. Bye.